Most developers think that mapping geospatial coordinates in an enterprise platform is a simple copy-paste task. But when you move from localized test sets to production pipelines, you quickly run into strict type validation, contracts, and platform cluster limitations. Today we are going to look under the hood of Geospatial Storage and Foundry and show you how we architected a stable, production-grade Geopoint contract. So we're going to start in Pipeline Builder, and I originally planned to deploy a streaming geotemporal series sync, but in trial or resource-limited environments, those advanced backend indexing clusters are often unallocated, which in this case triggered for me a raw 500 internal error on deployment. Rather than letting cluster limits block our velocity, we pivoted to the other essential geospatial primitive, Geopoints, which is static locations. It is fully supported, requires zero extra indexing overhead, and still lets us plot our operatives and missions as live interactive pins on our command maps. So to build this, I've kind of already opened up the mission logs clean node, and I'm just going to inspect what I've done for you guys. Inside our transformations, we have two steps. We have the create Geopoint step, which takes our raw target latitude and longitude and combines them into a Spark Geopoint struct. But here's a catch. You can't map a complex Spark struct directly to a standard database output. So more or less, the Spark Parquet writer will crash. Furthermore, the Ontology's Geopoint contract expects a plain string formatted as latitude and longitude. So to fulfill this contract, we changed our second step, which is convert to Ontology Geopoint. And this translates that complex Spark struct into a clean, simple coordinate string. By converting to a string format, our standard batch output tables, the mission logs atomic and tactical operations master curated tables, they kind of consume this column with zero Spark conflicts. So we pretty much map the clean Geopoint string to our outputs, and although I forgot, we can and should drop the temporary Spark struct. So, and more or less afterwards, when you deploy, the data will be successfully written to the disk, and yeah, I don't want to redeploy it, but let's dive into the semantic layer to see how the Ontology maps a string to an interactive map. Now that we're inside the Ontology Manager, on our object type, under our properties, we have the Geopoint property, and you can see that over here I dropped that specific column that I talked about. But anyways, when we inspect the metadata on the right, we can see the base type is set to Geopoint, and it's mapped directly to our Geopoint string column. Because our pipeline formatted the string exactly as latitude and longitude, the Ontology Manager validates the type contract with zero schema mismatches and gives us a green checkmark. So we're going to click Save to publish the configuration. And by addressing this string to point contract at the pipeline boundary, we bypassed a pretty big platform 500 error that I kept facing, which kept, now keeps our schemas highly optimized and successfully enables our front-end workshop map widgets to render our operations in real time. So now that our assets, history, and spatial properties are mapped, I think I'm going to think about how we calculate dynamic real-time metrics without duplicating data. So in the next clip, I'm going to look a little bit into derived properties and ontology logic.